All right, so we're talking about exponential functions, um, specifically exponential growth and decay. So to start with, let's talk about what an exponential, let's talk about what the exponential parent function looks like. So you may remember whenever we did parent functions, we did talk briefly about exponentials. If you don't remember, that's okay. I am going to refresh you. So the parent looks like this. Okay, we have some base. There's this A in front, and remember if that's not there, so let's say if this is missing, then A is 1, okay? And the B, this is just the base that is, of course, has the exponent put to it. And so I mentioned before growth versus decay. So this base is what tells us if we are growth or decay. So as B gets bigger, it's exactly what you'd think. As B is bigger than 1, we're not going to say bigger than 0. We're going to say bigger than 1, and I'll tell you why in just a minute. Then I have a growth graph. But if B is less than 1, then I'm talking about decay. So let me expand on this just a little bit because here B is never negative. So notice I said greater than 1 or less than 1. If there is a negative here, for instance, if I have y equals negative 2 to the x, okay, what this means is that a is negative 1 here. It's like a negative 1 multiplied because a is never going to be, b is never going to be negative, excuse me. Now, this value, that's my base, right? That's definitely bigger than, bigger than 1. So this would be a growth. Okay, so let's just give you a couple to look at, and you can take just a minute to pause and let me know if you think it is growth or decay. So let me just write it for you. Let's say 2 times 1/2 to the x. We'll switch it around and say 1/2 times 2. Let's say negative 3 to the x. And then let's say 4/3. So let's look at the first one. Okay, and this is not on your sheet. I'm kind of going off grid here to make sure you understand. All right, so looking here, the first thing I notice is that my A is 2 and my base is 1/2, right? So what this tells me, because my base is less than 1, this is a decay graph. Look at number 2. Here my A is 1/2 and my B is 2. So what do you think I'm looking at here, growth or decay? I hope you said growth, because you'd be absolutely right. And let's look at the next here. This one's a little bit tricky. There's the negative in front. Remember, B can never be negative, so this means A is -1. And of course, B is 3. And because that's bigger than 1, we are in a growth situation. Last one. Here, it looks like A is missing, right? You might be inclined to say A is 4/3, but that would not be correct. Here, A is 1, and B is 4/3. So again, I'm looking, is 4/3 bigger than 1 or less than 1? And of course, it's bigger than 1, so this is a growth. Okay, so just some ways to identify. Remember, it's based off of the B and nothing else. Okay, so now back to your guided notes. You've got this strange word on there, and it says asymptote. So I want to talk to you for just a second about asymptotes and what that means. So as I start graphing, I want to show you what these graphs are going to actually look like. First of all, an asymptote is an invisible boundary. I'll put invisible in quotes here. But it keeps the graph from ever crossing boundary. from ever crossing a certain point. So this is what it looks like. We dash it so that you know it's not part of the graph, but it's a horizontal asymptote, okay? But growth and decay have these horizontal asymptotes. And if I'm talking about growth, I am going to hug the asymptote this way and climb up really fast. Notice how it hugs this dashed line. It never crosses and never touches that dashed line. It's like this invisible boundary or border or line that is keeping the graph from crossing over or touching. And then, of course, decay. Decay does just the opposite. It starts out really big and then it starts dropping down and it starts hugging that asymptote to the right there. Now, as I start messing with reflections, of course, these could be upside down, but for right now, we're talking about parent graphs, and this is what the parent graph looks like, okay? So this is having an impact on my domain, on my range, excuse me. My domain for these is still going to be negative infinity to infinity, but my asymptote impacts the range, okay? And in a parent function situation, when I look this way, a times b to the x, my asymptote is going to be at y equals 0. Remember, that's a horizontal line right on the y-axis, okay? So let's do a couple of graphing. Let me walk you through how I think the easiest way to graph these would be. And then we'll move on to some transformation types here. So the first one on your packet here is f of x equals 2 to the x. Okay, so the first thing I want to know is it growth or decay? And if I look, my a is 1, my b is 2. B is what tells me that this is definitely growth. Okay. And then I also want to look at my asymptote. I know that my asymptote here is going to be y equals 0. Okay. So if I graph this, I just want to start at y equals 0. There's my asymptote. And now what I want to do, I'm just going to pick a couple points that'll be easy for me to graph. And if you think about what it is that I'm plugging into here, 0 is usually a good place to start, and maybe 1, depending on what your numbers are. 2 is enough for me for right now for you to get the feel of how this is going. The bigger you get, the more you plug in, the bigger those numbers really do get. But if you plug in 0 in this equation, right? So I'm up here in this equation, if I plug in 0, 2 to the 0 power is, of course, 1. So I have the point 0, 1. And then if I plug 1 into that equation, of course I get 2. So 1, 2. Okay, this is not a straight line, and if you need to graph a couple more points so that you see that, you're certainly welcome to. If I did 2, well, 2 to the second power is 4. So 2, I'm at 1, 2, 3. And you can see how it's really starting to climb up fast, right? So it's going to do something like this, and it's going to come back and hug that asymptote. So as I look at some analysis here of what's going on, my domain, like I said, it's negative infinity to infinity. But the range is definitely being impacted. If you look from the lowest up, 0 is the lowest, but it's not actually 0. It gets really close to 0, but it never becomes 0. So we use a parenthesis for this one, and then it goes up forever, so it's infinity. So there's my range. My end behavior, as x approaches infinity, so as I'm looking at the right side of the graph here, then my function is going up. Okay? And as I look at the left side, So as x approaches negative infinity, and here we go, it's a little bit different. The y is not approaching negative infinity, even though it's going down and getting closer and closer and closer to that asymptote, which is 0. Y-intercept, remember y-intercept is where it crosses the y-axis or where x is 0. Well, we already in our t-chart found out what happens when x is 0. When x is 0, y is of course 1. And then my asymptote that I already named is 0. Let's see. Let's do one more. Let's flip over with me, if you will, to number 5. That's still growth. Let's do number 4. So 4 is f of x equals 2/3 x. Okay. So again, let's look. A is 1, B is 2/3. So I am a decay graph because 2/3 is of course less than 1. And so now what I want to do, my asymptote here, y equals 0. I'm going to show you a trick in just a minute about the asymptotes and when they might not actually be 0. So let's see. Let's draw our axes on here. And here is my asymptote at 0. And now what I want to do is pick some points, right? 2 or 3 points is sufficient. I'm definitely going to choose 0 for one of them because that's my y-intercept, and that's a very convenient point to have. So 2/3 to the 0 power we know is 1, because anything to 0 is 1, right? And then let's do 1 here, and let's plug in. So 2/3 to the first power is, of course, 2/3. So don't get so caught up with being exact as you graph this. Just go up about 2/3 of the way, just like that. And if I wanted to keep going, I could. It might be easier to go negative, right? Because it's a fraction. So if I do 2/3 to the -1, remember those negative exponents flip, it becomes 3/2, which is 1.5. Again, two to 3 points is sufficient. And you can see how this graph is going to fall down and hug that asymptote to the left. So domain here again, negative infinity to infinity. It's always negative infinity to infinity for these graphs. The range from the bottom up, so I start at 0 and then I go up forever to infinity. In behavior, so as x approaches, I always start with positive infinity, which means I'm looking at the right-hand side of the graph, right? As I move more and more to the right, what is the graph itself doing? And it's getting closer and closer to this asymptote. It's never actually touching. It's getting close, 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 close. Never actually touches, so it approaches, and this is where I think the approaches makes more sense than the other graphs that we've talked about. But it approaches 0. It gets really close to 0. And then if I look at the left side, as x approaches negative infinity, the graph is clearly going up really fast on the left side, so it approaches positive infinity. So now, if you will, if you'll flip over and let's talk about some transformations, because this is really where the rubber meets the road here with exponential functions. So I'm changing here from a form of just a times b to the x to a times b to the x minus h plus k. Now, if you think back to function transformations, this all does exactly the same thing that it did before. The h is, of course, your horizontal shift. Okay, and if it's positive, it moves it to the left, and if it's negative, it moves it to the right. Your K is your vertical shift. If I'm going too fast through these, feel free to pause the video and write your notes down, whatever you need to write, and come back up and down. And then my A in the front, so it says if A is negative, So if this is negative, it means that I have a reflection over the x-axis, okay? And it just flips it upside down. So a reflected, if this is a growth graph, right, the reflection of that would look this way. So it's really, if it's reflected over the x-axis, it's going to be below my asymptote. And then of course A also, put this, well, we'll go ahead. As A gets bigger, and the absolute value, because remember the negative is still dealing with my reflections and all. So as A gets bigger, I'm talking about a vertical stretch. None of this is anything new. That's why we spent so much time in the beginning on function transformations, okay? Now there is one thing that I want you to add and star and highlight and do whatever. For these, if you think about it, when we were on these parent graphs over here, our asymptote was always 0, right? Always 0, everything we did. When we get into these transformed ones, your vertical shift up or down, this k, is always your asymptote. So y equals k is your asymptote. And then there's a point that's always on your graph that's an easy point for you to use where you don't have to plug in quite so much. And I always tell students to remember h, a plus k, and it'll help you with your transformations, okay? So this is opposite signs, and I'll show you exactly, this will make more sense in just a minute. This is same sign. But HA plus K is always a point on your graph. It's one you don't have to plug into a t-chart to find or anything of the sort. It just always is. It's there on your graph. So let's look at an example. Let's see what happens, and we will go from there. So first of all, with numbers 1 through 4, you're really just doing a visual analysis of the equation itself. So number 1 says that f of x equals 3 to the x plus 5 and asks you to identify the transformations, right? So here I've got the transformation that I have just moved up 5, and that's all we're looking for there is what's going on with the function, with the exponential here. Now I will tell you while we're here, this would have an asymptote of y equals 5 because this is my k on the end, right? And it makes sense because if you took the original parent and you moved it up 5, well, where's your asymptote going to be? It's not going to be at 0 anymore. It's going to be at, you guessed it, y equals 5. So that's why that works every time. And then I also know that there's a point on my graph, and if I come here, I know that A is 1, B is 3, which by the way means growth. H is 0, and K is 5, right? So a point on my graph, I could say is 0, 6, without having to plug anything in. Well, does that work? If you plugged in 0, 3 to the 0 is 1, 1 plus 5 is 6, and it does work. And it'll work every single time for you. All right, so just a good little way to, a little shortcut trick for you. I'll do number 4 and leave you with 2 and 3 on your own. 4 is f of x equals 1/2, that's my A, times 5. The 5 tells me that I'm growth again, x minus 4 minus 2. So what's going on here? I have a vertical shrink of 1/2, right? So if you can imagine that graph just being smushed down like you were smushing a cheeseburger. The 5, actually it told me the transformations, didn't it? Sorry. The negative 4 here says that I moved to the right 4. And the 2 tells me I move down 2. So now, let's talk about some things that happen here. I have an asymptote, right? And because my parent graph has been moved down 2, that means my asymptote is y equals negative 2. And a point on the graph. So let's just list out A, B, H, and K real quick, just so you see where these are coming from. A is a half. B is 5, so again with the growth. H is 4, and K is negative 2. So this tells me that one of the points on my graph is going to be 4, A plus K, right? So H, A plus K. So that would be, negative 2 plus 1/2, which would be negative 1/2, right? So negative 3 over 2 or negative 1.5, whichever you prefer. Okay? All right, let's actually graph one or two of these, and then I'll let you finish the rest on your own. Let's look at number 5 first. Actually, let's move to a little bit harder one. Let's do number 7. All right, so we've got f of x equals 1/2. That's my a. That's not growth or decay. That's just my a. 3 to the x plus 1. Okay, so what do I know? Well, I know that it's growth. That's what that tells me. I know that this is my asymptote. What else do I know? I've got a vertical shrink of a half, and I've moved up 1. So let's graph it. My asymptote is happening at y equals 1. I always start with that. Okay, then I start with my easy point. Well, I know that h, a plus k, is an easy point on my graph. Well, here, h is 0, a is 1/2, and k is 1. So the point 0, 1.5, I know is on my graph. There we go. I really only need one more point. So let me do my little t-chart here. I've already got 0. I know that comes out to be 1.5. So maybe now I try 1. You really want to stick close to this point because the further away you go, remember how fast growth goes up. It's going to go up really fast. So you want to stick close to that point. So if I plug in 1, well, what is f of 1? F of 1 is 1/2 times 3 to the first plus 1, right? So 1/2 times 3 is 3 over 2. 3 over 2 plus 1, and if you have to use your calculator, use it. But this is 1.5 plus 1, which is 2.5, or 5 over 2. So 1, 2.5. And now I have enough to do my graph. Okay, let's finish the analysis on this then. So my domain, of course, negative infinity to infinity. My range, 1 is the lowest, so it goes from 1 to infinity. In behavior, as x approaches positive infinity, so on the right side, my graph is going up. And then on the left side, my graph, it's not going down, even though it is going down, but this asymptote is bounding it, so it's approaching 1 here. All right, so if you'll get the rest, so you have 1 through 5 on the first page, and then 1 through 9 on the next, but we've worked through several of those together. So if you will get those done, we'll talk about any questions you might have on Monday.